In this video, I'll be showing the process of adding S390X architecture compute nodes running on IBM LinuxONE with Red Hat Enterprise Linux KVM to an existing OpenShift cluster that is running on distributed hardware of the AMD 64 or x86 architecture. So this so-called multi-architecture OpenShift cluster is a great way to build a hybrid cloud environment where you can run containerized workloads where it makes the most sense with a fit-for-purpose model without having to build a brand new OpenShift cluster for each new architecture. It's important that the existing x86 OpenShift cluster is set to platform none. Platform refers to the infrastructure provider like Azure or vSphere. Since IBM LinuxONE requires user-provisioned infrastructure for OpenShift, where platform equals none, you can only add S390X nodes to a cluster that is not already managed by an infrastructure provider. While mixing architectures like AMD 64 and S390X is supported, mixing infrastructure platforms is not. So let's take a look at the existing x86 OpenShift cluster. I'm going to print out all of the nodes in that cluster, and you'll see that they are all running that AMD 64 architecture. So now we're going to have to check that our OpenShift cluster is actually ready to be run with multi-architecture nodes. You can do that by checking the metadata of the release info for your cluster. And you can see that we don't have anything that references multi-architecture mode in this current cluster. So what we have to do is actually upgrade our cluster to enable multi-architecture node, and that's what we're going to do with this OC ADM upgrade to multi-arch command. This will kick off an upgrade to your OpenShift cluster, so you can either monitor that with this OC ADM upgrade command, or you can swap over to the OpenShift web console, which provides a nice way to watch the status of your OpenShift cluster. You can see that we've got an upgrade in progress. It's partially complete, and we are just going to sit around and wait for that to finish. So the command line has told us that the OpenShift upgrade has completed, and we can see that in the OpenShift console as well. But what you should really watch for is these cluster operators, because that upgrade will trigger new containers to be deployed into your OpenShift cluster, and it might trigger a upgrade of your kubelet service running on the CoreOS operating system for your OpenShift nodes. So really we should wait until all of these cluster operators are reporting back to be available and no longer progressing and no longer degraded. So don't do anything until these cluster operators are all completed. It looks like all of our cluster operators have completed their updating, and I'm also going to really quickly check that the nodes in the cluster are all still ready and healthy, which it looks like they are. So now let's go ahead and run that OC ADM release info again and look at the metadata for our cluster to see that the architecture is now set at multi, which means that our cluster is prepared to add multi-architecture nodes to it. Now back to the documentation. We need to disable UDP aggregation for this cluster because it's not supported on IBM Z and LinuxONE, so that would cause issues if it's activated, and that just won't work on LinuxONE. So let's disable it by creating this config map here on the cluster. And we're just pasting in from the documentation and running an OC create-f on that YAML file. Back to the documentation again, we're running this OC extract command to pull the ignition config file for compute nodes out of our existing x86 OpenShift cluster. And we're going to move that to a HTTP server. In our case, it happens to be running on this Bastion node, so it's nice and easy to move it in there. But in your case, you might be running your HTTP server elsewhere. So just make sure you put it in the right place and make sure that your KVM host running on S390X on IBM LinuxONE can reach that HTTP server. We're basically going to repeat that process for 3 other files: the kernel, the init ramfs, and the rootfs. We're going to pull all these out of the existing x86 OpenShift cluster. So again, just copy these commands from the documentation, and they might take a little while depending on your network speed. So just be patient and pull them down, however you did so in the previous step, and again move them into your HTTP server that your KVM host has access to. Now, all of the required files from the x86 cluster are available to our KVM host running on IBM LinuxONE, and we're now able to start creating the virtual machine for that new compute node. I'm going to go back to the documentation, scroll down a little bit, and you'll find this virt install command. Now, the virt install command is used to install virtual machines on a KVM host. So that's how we're going to be installing this compute node on S390X architecture. Now, there's a lot of different variables listed here: the VM name, number of CPU, amount of memory, but more importantly, the location includes the files that we have loaded in our HTTP server that we pulled out of our existing OpenShift cluster, as well as the CoreOS ignition files, or the CoreOS files and the worker ignition file that we have also in our HTTP server. So we're going to use all those files that we previously pulled out. Now, you're going to have to fill out all of these different variables with what is correct for your environment. In the interest of time, I've pre-populated the command with what is correct for my environment. So you can take a look at mine if you wish, but yours is going to be different, and you want to make sure that you're modifying it for what is right for your environment. So now I'm on my KVM LinuxONE host. So just to show that this is running on the S390X architecture, let's just look at the architecture here as S390X. And this is running RHEL 9.5, so I can just look at my Red Hat release file and see RHEL 9.5. So I already have KVM installed. I don't have any virtual machines currently running, but again, this will be populated with my upcoming command that I'm going to run here. So let's run that virt install command, and we're going to sit around and wait for it to come up. You can see that it pulled the CoreOS files out of my HTTP server, so obviously we've got good connectivity there, and it is now waiting for the installation to complete. Now, rather than sitting and waiting on this page and just waiting for this command to finish, what I like to do is go into the KVM browser window and look at my virtual machines. Now, you'll see zcompute1. This is new because I named my virtual machine zcompute1 in my virt install command. And if I go into zcompute1, you'll see a definition for a virtual machine. Now, the console is not going to be able to reach the VM right now. I think I might be able to now. And you'll see that it is actively building out this virtual machine for me based on the install command I provided, as well as the ignition files and CoreOS files that I pulled out of the other OpenShift cluster. Now, we're just going to sit here and wait for this console to show that the worker 5, or work 5 as it's named, is up and running and at the login prompt again. It does reboot a couple times during this install process, and it's going to start setting up some different container images and the kubelet and the OpenShift internal networking on the node. So I'm just going to be patient here and just wait until it looks like it's done. Now what I'm going to do is go back into my my command line interface in my terminal, and I'm actually going to go back to my x86 Bastion node. Now, the final step here is to approve the certificate signing requests, the CSRs that are created as part of that node coming up. So once the node is ready to be added into this cluster, we should see some CSRs in the x86 cluster. So let's see, OC get CSR, and you'll see we have 2 certificate signing requests for the API server client kubelet. So I'm going to approve both of those. You don't have to copy down this command. This is in the documentation, so just copy it from there. So I've approved both of those CSRs, and now there should be one more that's created. And we see we've got another pending one here for the kubelet serving CSR. So let's again approve that. And if we look at our nodes, we should now see work 5 is not ready. This is a new node. It's 20 seconds old, but very soon here, if I just do watch OC get node, we should be able to see when this flips over to ready, and then our new node will be added to the cluster. So let's wait for that. All right, the node is ready. Our new node is added to the cluster. Now let's just make sure that this is in fact running on IBM LinuxONE with the S390X architecture. So instead of OC get nodes, I'm going to add the label for OC get nodes with the label of kubernetes.io/arc. And now it'll print the architecture of each one of the nodes as another column. So the arc for most of my nodes is AMD 64, but at the very bottom here, work 5 is an S390X node, a worker node for this OpenShift cluster. So now we have a mixed architecture or a multi-architecture OpenShift cluster, and we can determine whether we want a application to run on either AMD 64 or run it on S390X, all within the same OpenShift cluster. All right, thanks for watching.